Hi and welcome to Anrisu. I am Navneet Kataria and I'm the product marketing manager for Anrisu benchtop product line. In this video, we are actually very excited to announce the latest addition in the VNA family for shockline VNAs. The system that we are going to introduce and announce is the PhaseLync ME7869A system. The PhaseLync ME7869A system is the world's first VNA, which we call as distributed and modular VNA, because the two ports of the VNAs can be separated out by distances as long as 25 meters, 50 meters, and 100 meters, and the VNA is still able to make vector-corrected S-parameter measurements. So this is a very unique concept because traditionally in a benchtop VNA, you have two ports of the VNA in the same box, and the synchronization between the two ports is actually pretty simple to make for LO and for other signals. However, the moment you separate the two VNAs out, you have to have a very specific technology that could do the synchronization and the LO sharing between the two VNA ports. And Anrisu was able to do that. Anrisu has always been a pioneer in introducing new technologies. So this time what we did was we separated the two ports of the VNAs out by longer distances and still be able to make vector-corrected S-parameter measurements by using a technology called as PhaseLync. So the PhaseLync technology is the heart of this concept of the VNA, and it has been working really well. We had another version in the name of PhaseLync ME7869A, and we have improved a lot of feature-wise and added few more things, which gives a lot of flexibility to our users. So taking a deeper dive into the new PhaseLync ME7869A system, you will see that there are three components, in fact 4 components to the VNA that can make fully corrected vector S-parameter measurements over longer distances. And the 4 components are 2 ports of the VNAs. Again, the VNAs can be configured for different frequency ranges and with different software options. The standard software options like time domain in the VNAs. And then we have 3 frequency options, 8 gigahertz, 20 gigahertz, and 43.5 gigahertz. And then what you're seeing here is a cable set which basically is providing all the synchronization and power signals to the VNA heads, which are coming from this very special control module. Now this control module is powered by the mains, so that's the main power source. However, this control module supplies powers to the 2 VNA heads. So the VNA heads, again, as I said, could be spaced out in like 100 meters apart from each other, and the power to the 2 VNA heads will be supplied by the control module. This control module acts as basically a router for the synchronization between the 2 VNAs. So you can see that left half of the control module is getting the signals from and to the VNA from the control module and vice versa for PhaseLync optical, electrical, and USB. And then the signals are routed internally to the second VNA. So the loop is like this. So the synchronization between the 2 VNAs is happening through the control module, and it also supplies power to the 2 VNA heads. Apart from that, the control module also has a USB connection that gets connected to a computer in which you have the shockline software running, and where you can make S11, 12, 21, and 22 measurement. So this solution is very unique in the way that especially for customers making long distance measurements. So you could have antennas inside a very long anechoic chamber, or sometimes we have seen a lot of users doing outdoor antenna test ranges where the distance between the 2 VNAs is actually of the order of more than 50 meters or so. This also is very useful for testing long structures or long airplanes and trains and ships, because in a plane you have cables all across the wings from the cockpit, and they have to be phase matched or phase stable, or if there is a break in the cable, that needs to be detected as well. So The wingspan could be like 10 meters or 15 meters, and the only solution that the customers had till today was to use a benchtop VNA which has 2 ports of the VNA embedded into the same box, and then they had to use very long and lossy coaxial cables and then connected to the 2 ends of the cables or antennas in case of anechoic chamber. The problem there was that these cables were producing a lot of insertion loss, and that's why the dynamic range was sometimes not enough for antenna customers. So that was first challenge. Apart from that, since we are seeing higher and higher frequency antennas and applications coming around at higher frequencies, the slightest of the movement of the coaxial cables actually creates a lot of phase instability, and the measurements does not look good. So there were a lot of challenges, and customers were forced to use makeshift arrangements by using a down converter and sometimes using optoelectronic extenders, which had their own issues as far as the temperature stability and magnitude and phase stability is concerned. With this new concept, again, we do a lot of phase compensation with the PhaseLync technology, and our phase stability is very flat. You can go and see on Anritsu website, we have a full technical data sheet available. But again, the beauty of this system is that you could have long distance measurements, you could have antennas, you could do a TFR cal, you could do everything that a normal VNA specifically for those applications is able to do. Now coming on to these cables that you are seeing on the right and the left, so there is a choice to the user wherein they can have different lengths being connected between the 2 VNA heads. In this particular example, we are using a 5 meter and a 5 meter, so the total distance between the 2 VNAs could be 10 meters. And in this particular case, the control module sits right in the middle. However, it's not a mandatory thing. The users can choose to buy from various length combinations. The combination on the lengths that we have is, it starts as low as 2 meters and 5 meters, then 10 meters, 25 meters, 50 meters, 75 meters as well. And then you could pick and choose which side needs to be longer or shorter. So for a user who needs to make 100-meter distance, they can either choose to have 50 meter and 50 meter, or they could choose a 75 and a 25 meter. So there is a lot of flexibility in this solution. The other thing to note here is that a user who's, say suppose today only checking the resonant frequency of antennas, right? Maybe at 28 gigahertz and 39 gigahertz because of 5G FR2 bands, or even higher up to 40 gigahertz. So a user could actually start with a 1-port VNA, and the VNA can be directly connected to a computer, and you can see the S11 or S22. And then later on, if you still want to make vector corrected 2-port S-parameter measurements, then you can upgrade the VNA with some software and hardware options to actually work as 2-port VNA. So again, the upgradability is always there. And then with required hardware and software options, you could scale up the distance as well. So initially you could be making only 1-port VNA measurements, then you enable the VNA to be upgraded to be used with another VNA with software and hardware options, and say have a 5 meter and 5 meter system. But in future, if you want to upgrade to even more distances, the user can just buy different sets of cables from Anritsu as well. So again, the good thing about this solution is very flexible, very stable measurement wise, no need of long lossy coaxial cables. The PhaseLync technology is very proven, and a lot of customers across the globe are using these VNAs with the PhaseLync technology. And Anritsu has always been pioneering into bringing new technologies to the world. So I believe this system is very useful for our antenna customers, for customers making long-range S-parameter measurements. I hope you like this small demonstration and introduction. If you have any further questions on the ME7869A PhaseLync system, please don't hesitate to contact your Anritsu closest contact. Thank you so much for watching. Thank you.